So in order to set up the Kubernetes, right? So what I did, I have a mini PC of Ubuntu, and I have one more. This is a Raspberry Pi. So this is Debian OS, and this is a mini one. So we'll use it this one as a worker agent, and this one as a master. Okay. So before going further, like I'll not go complete list of advantages and all. So, but what we seen, the problems what we faced with the Docker, like just to re-summarize it. So one problem we faced with the IP addresses and ports, like so we seen like all the yeah. I hope my voice is audible, right? We good, right?
Yes, yes, yes.
Yeah. So one problem we faced is with the IP addresses and ports. So I don't want users to remember where is my IP address, where is my port, where is my service running. So we'll go switch to services. So we just name it as a service. Okay. And one more thing is a load balancer, as in Nginx or Ingress, you can say. Okay. We have one more as a build. And scaling. So scaling, yes, the Docker Compose does support scaling. I mean, Docker Swarm does support scaling, but scaling with plain Docker will take a lot of efforts. Okay, so scaling as in I want to change. Let's say I have one container or two containers of basic. So I would like to deploy it as 50 containers or 30 containers or somewhere, or let's say five. Okay. Now the problem would be how do you handle the nodes? Okay. So you'll spin up a new node, uh, and then you will set up the Docker install inside. Okay. And then you'll bring up the things. Okay. Like even the last demo, right? So I was trying to port forward from Nginx to, I mean, I was trying to map from Nginx to Docker and all. So the time I'm spinning up a VM, installing the things, so it's taking a lot of effort. So the node setup also it's a big problem. So and one other thing, health issue, as in the recovery. Okay, see, I can set up a monitoring on top of everything, but I would like something like, okay, if something goes down, I would want this one to come up automatically. Okay, I don't want some, let's say, or some node goes down. Okay, so I would like to spin up another one automatically. It's like a self-managed. Okay, so I would like all these things, like will build is not a problem. So far in the sessions we discover, like we discussed, these are the problems which we faced. Okay. So let me log into, that's the reason we needed something for the orchestrator. So all these containers were whatever are there. So we need a manager, like, so here the, so we need someone, a manager, to take care of these things. Okay. So do dedicatedly, like if something going wrong or what is happening over the cluster, right? So all these things. So we need some orchestrator to take care of these things. So we have multiple things, like one is Kubernetes. So this was used by Google inside, like as a Borg. Okay. So we have a Apache Mesos. And we have several other things, but the Kubernetes got the, since it was adaptable to the users, so we are going with the Kubernetes. Okay. And over the time, Red Hat took it and they made the OpenShift for their enterprise customers. And we have Amazon EKS and Azure AKS and GCP GKE. Okay. So Google Kubernetes Engine. And yeah, there are others, but these are the prominent names. Okay. And we can discuss in deep further. So what's happening or how it is going and all. So it's a vast topic. So for now, what we'll do, we'll spin up the things over here. Okay. So Okay, so I have a the Kubernetes cluster already set up. Okay, so for the people concerned, right? Like, let me set it up from scratch again. One more. Yeah, just a second. And I'll do a reboot. This. Yeah, this one is coming up. So I'll go to official gate. Okay, Kubernetes stores. So there is a reason I'm taking K3s. So there are two versions. So for Kubernetes, so one is K3s and K8s, and K-Lite. You have Minikube also. So since my setup is a very moderate one, so I'm going for K3s. Okay. Uh, I'll see the steps. So I have to see the requirements. These are the supported environments. Okay. And so this is the steps. Okay. So I'll go through one by one. For this, they provided a quick start script. Let me see. Yeah. So this is the one. Yeah, so this is the basic install script. Okay, so this script will take care of everything. Okay, so I'll do this in this mini PC. And so once master is done, so master will provide a token and then I can join the worker node. Okay, so this is the master. Yeah, so this is the master. So master will provide a worker node token. So after that, I can rejoin this. Okay, so let's wait for that. Okay, so starting K3s, sudo kubectl get mouse. So this is the command line. This is the utility we use, kube control. So kube control allows us to communicate with the Kubernetes cluster. So these are all the steps it performed. Okay, so we'll go through one by one. And all I can see is my master is healthy. Okay, it has Kubernetes 1.33 and it's saying it's a control plane and the status is ready. Okay, so it should provide a token here. Wait a second. Yeah, so this is the one. In additional agent nodes, add them to cluster with this K3s URL. Okay, so there should be a token. So yeah, so this is the node token. So what will I do? I'll construct a command. So this is the command. And so I need my server IP as a server DNS name, anything. So I'll provide my server IP 192.168.0.74. So I can just check if the master is responding. Okay. So here, this is the port number 6443 where your Cube API server will be running. So I'll explain the components. So from the Pi, I'll try to check if it is connecting or not. Okay. So curl hyphen KV. So yes, I'm getting the response, even though it's saying unauthorized. I'm getting the response from 6443. So, and then let me put my token here. Yeah, I'm trying this command. And we can check the master side if we got it got registered of our owner. Okay. So let's go here, of our node. So, okay. Still spinning up. Okay. So let me check. So yeah, here we are. So we have a master and we have a node like as a worker node. So both are being set up now. So we can start deploying further. So before this, I'll show you what are all the few components which will be there. Okay. So the two physical components here are the nodes. Okay. So these two are a physical component. So these are the physical components. So one thing we will check is so okay. So this one will show you the status of this. Okay. So this will create a pods. Okay. Pods are a Kubernetes component. They are not exactly containers. So they are a let's say a box kind of thing to host the containers. Okay. So we have one. Um, Okay. So this one has a system pods and application pods. Okay. So the system pods, like you can call pods as something called holders. Okay. Container holder. Okay. So the next level we have a containers. Okay. So each pod usually will have one container. Okay. There is place, it's not guaranteed, but there is places that sometimes yeah, yeah, so there's places that sometimes one pod might have a different containers and all. Okay, so usually there will be one. So we'll map to this. Okay, one second. I need forward. Okay, so each pod will hold one container. So we'll go and check what's happening. Okay, and there are as I told, there are system pods and application pods. So we will check what are all the system pods are there. Okay, so I'm here in the master kubectl get pods hyphen all namespaces. Okay, so looks like this deployed with the help of Rancher. Okay, uh, once. So let me check the pods. kubectl hyphen a. So if you see, we have all the containers running, which are mostly system containers. Okay, so I can give open wide. So we have core DNS. We have a Helm running. Helm has been recently, I think it came as a common component with the help of Rancher. Okay. So we have a metric server and we have a traffic. Okay. So, and this is the only server, the service load balancer traffic. Okay. So this is the only process which is running inside the my pipe, the worker node. Okay. So let's go with the architecture ones. So this is all I remember. Like let me put it here. So you have one something called Kube API server. So this is like a master, like in the master node. So this is the main component, as in like everything will go via from this. So the API server will authenticate, or API server will proceed. So everything, all requests will process through the API server. Okay. So we have a etcd. It's an additional component. So we do use it, but things changes once in a while. So we'll keep it here. Okay. So as a data store. Okay. And we have a control plane, controller. Okay. So the cube DNS, it's an additional one, core DNS. And we have traffic. So, yeah, yeah. We have a scheduler. Okay. Let's check the architecture. So this is the one. So we have a cloud control manager. This is for the clouds. So we have a etcd, we have a scheduler, we have a controller manager, and we have a Kube API server. So where all the communication will go via this. Okay. So I'll keep this one as here, and yeah, let's keep the etcd, scheduler, and control manager. So let's keep this one. And so if you ask me what is the purpose of each, so etcd will store all your pod configuration, okay, where and all what components are there. So it will store the data. So it's a data store. And scheduler will help you assign the pod. Let's say I want to assign this pod to different nodes, okay, or I want this many pods to be split up, or I want it to be scaled like this many things, okay. So all the scheduling operations, the cube scheduler will take care. So controller will help you, like, okay, if the health is bad, or if you want to spin up, like if you need to stop the pod, okay, you need to assign it and all the things will be handled by controller. Okay. So we have a cube worker node actually. So kubelet and kube proxy. So this is the one which will be running in your agent, which in your worker node. Okay. And this is they call it control plane. So control plane is nothing but master. So in cloud environment, what exactly happens is hold this thing. Okay, wait. Yeah. So in cloud environment, or in your EKS environment, or anywhere, so what exactly happens is whole this thing is masked. Okay. So everything is managed by cloud. Okay. So that would be send words. Yeah. So this whole thing is managed by cloud. Okay. Your AWS or GCP, they will handle it. Okay. And you have something, one component, as I mentioned here, CCM, Cloud Control Manager. Okay. So this will help you communicate your code. Okay. So now your worker node has only one thing, kubelet, and you have also kube proxy, which will help you, connect to the kube. So, and yeah. Okay. So I'll go with another one. Okay, so this is the overview of your architecture. Okay, so far, what we did, we spinned up a cluster. So I'll show you what is there exactly inside the spin up. Okay, uh, setting up a cluster. Okay, main components. Okay, so the installation instructions are here actually. So yeah, so you have different ways. So you can set up with deployment tools. So we have kubeadmin. So kubeadmin will check this. So before you begin, so you need to have the this many requirements. Okay, so you need to have 2 GB RAM and two CPUs. Okay, so you need to have a full FQDN connectivity as in the DNS. Okay, and there is a list of kernels it supports. I think these days they are running containers in Windows also. So I think with the Azure part, and it also has needs to be open this particular ports. Okay. So coming to the container D, I'll show you what is container runtime. Okay. So what happened exactly? The people try to replace, I think in the beginning of the session we mentioned. So we have a Docker. In the Docker, we have a container runtime. Okay, so this is the child. Actually, you can say the container runtime is the child and Docker is the parent. So Docker has three things like you can do build, run the containers. So, but in inside it uses the container runtime. Okay, so you have container D, you have CRIO, and you have a Docker shell. So in earlier days, the Kubernetes earlier versions, it used to support with the plain Docker shim and all, plain Docker. So now it's run, it's cleaned up, and they are preferring to use the container D or Creo. Okay, so in order to go forward, so container D is nothing but it's a sub component, the core component of the Docker. So we're gonna use it. Um, it's yeah, I can say like this. So we'll use only this component further here. And yeah, we can use Docker shim also, but most of the clusters, right, they are preferring to go with the container D. Okay. And yeah, that's all. These are all the basic instructions. So let me go through one by one. So here they are installing the CA certificates. So let's make a note. And yeah, kubeadmin. I'll go to the next one. Yeah. So this is the one we'll initiate with the kubeadmin. So we'll initiate the cluster. So on top of this, if you see the Kubernetes architecture, right? So you need two more things. Okay. So you have a traffic, which is nothing but working as an ingress here. So we have a core DNS, and you also need a network plugin. So you have Falco, or you have different things. Okay. So yeah, so you have this many supported network plugins. So the most used are Calico, Cilium, sometimes Weave, and Falco, and I think Funnel, right? So we will check what is it which we are using. Okay, I think since it is K3S, right, I'm not able to see which one they are using. So it's happening, it's managed locally. So I can check in the K8S setup. Okay, and I'll also explore the shell script, whatever we did. So let's go that one. So this is the shell script. And if I keep this one to local, this is the setup environment. They are setting up the services. Kubernetes install, finding the release. So they're trying to find the release for the Kubernetes kubectl. Yeah, so they're getting the release versions from here, the downloads for the binaries. Unzipping, they're extracting it. So based on the OS, they are installing the particular container, container related packages. Mm, yeah, so they're updating the C group related things. So we discussed the C groups and namespaces concept earlier. So the Kubernetes uses this one to communicate. Okay. Yeah. So that's all. It's a let's say whatever I set up today, it's a mini version of what you're using in the production. But this should give you a basic overview of what's happening. I think the reason which we don't see because of the K3s, the etcd, we are not able to see. Okay. So far two things we discussed. Even though in the light version for the so maybe next time I try to bring up a K8s setup from the scratch, maybe at the end of the session. So we discussed about the setting up a cluster and setting up the components. So any questions here till now? Is it okay? Shall I move forward with the deployment? Yeah, Prasad, Asupit.
Yeah, yeah, sure.
Look. Okay, so we'll move forward with the deployment. For that, we will see what are we have in our hands. Okay, so we have a K3s cluster with a master and a worker node. And in the previous sessions, we deployed multiple applications with the Docker. So we have a Docker. We have a Docker image we built. Okay, so we are not going to build a Docker image anymore from the ongoing sessions. So we will not build the Docker image on the nodes. So we'll build it outside and push. Okay, so we have a Docker image and we have a CI/CD pipeline for that. So let me show you that. So yeah, this is the man Docker, and yeah, this is the thing. And let me show you the pipeline. So this is the workflow file. So basically, it's doing the Docker build and pushing it. So it's doing for front end and back end, and it's basically doing for my men stack build. Okay. So let me check the Docker hub. So yeah, I pushed the images 1 hour ago. So for your sake, I can push the images now again. That should be okay. So if I go to GitHub Actions, so for people who are new or who are not following, so we discussed GitHub Actions and Docker in the earlier sessions. So I have a somewhere I should be having a yeah, this should be the run. So I can trigger the pipeline through this option. So we mentioned a workflow dispatch option. So that should be, let me show you that. Yeah, so we added two things. So whenever there is a pull request, it's supposed to run. On workflow dispatch as in someone is manually running, so you can trigger the pipeline. So let's trigger the pipeline and run work. And we prepared some manifest files for it. So let's go inspect that. I'll do a git pull. Hmm. Yes, boss. So whatever the image, mon image we have, so I improved it like in order to make it look better. So I upgraded all the changes here. So I also added these files. Okay. So I'll explain what is the manifest files here, and then we can use it for deploy. So far we have three things. Okay. So we have MongoDB. We have a MongoDB. So which is running in one particular port, and it's basically we are starting it from the scratch. So this is the deployment file we written for that. Okay. So the main thing which we are seeing, so this is the type of the kind deployment. Okay. So we have, so as I mentioned, so we have a pods, we have a containers. Okay. So we have a deployments which will manage the pods. Okay. So what happens is the pod it's a single entity. Okay. Let's say if a pod gets killed, that's it, it's gone. Okay. So the deployment will tell the number of pods we can run. Okay. Like I want to run five pods. Okay. So I can do a scaling. So I want this many pods. The number is equal to one. Okay. So, and I also, what do you want my name of the container? Okay. So name of the pod. And what is the image of my pod? So I have three images. So one is MongoDB, one is backend, and one is frontend. Okay. So this one has a different port number, 655 something. So this one has a different port number. I guess it's 5000. And this one has a different port number, 3000. Okay. So we have the names, we have the images, we have the pods. Okay. So let's go and build the deployment file. So this is all we have in the deployment file. Okay. If you see the spec file, so this is what we have. What is the container name? What is the image? And what is the port number? So the volume mount, it's similar to Docker mount. So we'll provide a volume and we'll attach it to it. So this is where we are creating a volume, empty volume, and we are attaching to our pod. Okay. So let's go here. And if you see here, so the deployment, it has a template. Like, so it will create multiple pods with the same template. Okay. That's the reason we have a template here. And we have a labels. So for each thing in the Kubernetes cluster, so everything will go via labels. Okay. So you want to do something or you want to add some more component. So everything should go via labels. And we have a selector. So this particular deployments we are selecting, like, okay, which ones to manage. Okay. Let's say if a pod is already created, we want to add it to our deployment. So we can use this one. So we are mentioning the same labels here also. And this is the name of the deployment. Okay. And this is the syntax we are supposed to follow: API version, kind, and metadata. Okay. So slowly using, regularly, you will get used to this. Okay. Other than that, we have a service. This is service is the one which will tell how to access this particular container. Okay. It's like a port forwarding. So this is the source port. This is the target port to do forward from. And here also, as I told, we are selecting the labels, okay, which is the deployment you are targeting. So this is the one. So I'll select these labels over here. So this is about deployment. We will revisit again and again. So we will get until we get a confidence. We have a backend. So backend also works the same. So all you have image where it is pushed. So my image is pushed to Docker Hub, right? So I'm using this one. Okay. And image pull policy always. So whether do you want to pull the latest image always and all. So here it is. As I told, MongoDB, the replicas is, we didn't mention the replica count. So usually it will be one. For backend DB, the replica count is one. For front end also, the replica count is one. So backend, we are saying it will run port 5000 and front end port 80. And we have ingress. We'll come to this part later. Okay. So what we do so far, this is the architecture we have, right? Yeah. So far, this is the architecture we have. So we have a Docker image, and what we are doing, we have a Docker code. Okay. So we are building a Docker image for it. The reason why we are still creating with Docker, like since we are used to it, we can switch it to different buildx. We have a Docker buildx command, so we can use that also. So Docker image. So it's stored to ECR, like the container registry. Okay. So that one is Docker Hub. Okay. And once it is done, so we have a K3S. So what we want is we want a manifest file. That's the language K3S will understand. Okay. So we have a K3S Kubernetes manifest file. Okay. And we can use it to deploy. So we have two things here in the under the manifest file. So we have a deployment and we have a service. Okay. So under the deployment, as you know, we have a pods. And I think if you are aware, we have a problem dealing with the stateful set, stateful application where you are storing the data. Okay. And stateless application, right? So all our web applications, all are stateless. Okay. But whereas your database, okay, you have front end and back end, right? So where we have a database or a Jenkins storage or Redis, anything. So this is you can call stateful application. Okay. Okay. So the way we are dealing stateful application is a bit different. Okay. So we'll explore that one later. But for now, we will go with the stateless applications. Okay. As in a web and all. Okay. So the service will talk to pods. Okay. And we have an ingress on top of this. And the user. So this is the setup. And let me, yeah. So this is the whole setup. So we have everything here. So let's go and initiate this. Uh, so I'm in my mini PC. CD data plane. We have something called namespaces. Okay. Yeah. See, this is the cube system namespace. We have a different namespaces. Okay. Get get namespace. Okay. So we have a default namespace. So we are deploying everything today in the default namespace, but the next time onwards we will try to deploy in the different namespaces. Okay. So cd data 01. I do have it deployed somewhere. Docker to. So monster. I should do a git pull. Just a second. You. So I have the KTS folder. So as I shown you, so we have these are the things. We have the YAML files. Inside that we have wrote a deployment file, service file, and ingress. So I'll move ingress out of it for now. Okay, I don't want ingress to be deployed. So ingress.txt. Or I will just keep it. Okay. So the order should be first you want to deploy the MongoDB. So the command would be kubectl apply-f mongo. Mm, okay, I'm in the default user. So sorry. So kubectl apply-f mongo. So it said MongoDB created, deployment created, and service is also created. Okay, so let's check it. Kubectl get pods. So it's still creating. So it's saying container is creating. Okay, and then we have a SVC. Kubectl service. Okay, so we have a default Kubernetes service. So as I told, each component will take time, to explain and debug further. So yeah, let's see. I'll show you in the next session what is this services and why we are using it. So yeah, we have MongoDB which is running on this port number. Let's run it again. So the pod is running now. So what will I do? I'll deploy the backend again. Okay, so the backend also created. So now I'll run the front end. Okay, so now I'll check the status of everything. I think there is a problem with image pull, but let's see. Let me check. kubectl describe. Okay, failed to pull the image front end latest. Okay, the no match for the platform manifest not found. Let me check the Docker repositories. And yeah, it got pushed. I think the problem is with the platform compatibility, but let me check. Mm, okay. I think the problem would be because I'm trying to run on a different node, but let me check. So odds wide. Yeah, so there is one problem which I faced. So I kind of aware of the error which we'll run into. So the problem is we have a VM of one type, the master is one type, and the node is of different type. So this is not an ideal setup we do it in. So the master is x86 architecture. Okay, so this is x86 architecture, and the worker node is um, ARM. Yeah, ARM architecture. Okay, so since it is a pipe. Okay, so we need to handle this. So there is a way we can ask this guy to install in the master node itself instead of trying in the worker. Okay, so let's do that. Or we can push a different image, but let's do it for now. Let's go ahead and go to front end. So what is our node name? kubectl get nodes hyphen override. So we can hard code this one to run it in the different labels. Okay, so we can ask set up any labels here, and then we can run it. Or for now, we can simply say run this one in the particular node. Okay.
So currently the backend in Mongo nodes, I mean, those pods are in which system, like the Raspberry Pi one or mini computer?
Yeah, you can check here now. So yeah, here it is. See,
Okay.
this is one problem. One of the problem Kubernetes helps you deal. Okay. So the problem is you have a different type of VMs. Okay, different types of nodes. So you want to set up the make sure your pods run only one different type. Okay. So you can label this master node. Okay, add a label and ask this one to deploy it only on this label. Okay. But that is little advanced concept. So what will I do? I'll just mark it for now. I'll do it now right now. Okay. Let's add one second. Or I can build a Docker image for the ARM, but let's not do it. Let's try this way. Okay. Uh,
Like where did we specify that we are using ARM architecture? Like did we mention somewhere in the Docker file or something?
no, no, I didn't mention anything. I didn't told anything to Docker or anything. No, I'm saying, okay. So here it is. So I have my mini PC here. Okay, that is a regular server. Okay, but I have my Pi running, Raspberry Pi. Okay, so I think this is the one. Okay, like in the very beginning session, I told about this
Yeah.
Raspberry Pi. So this even your Mac also runs in the ARM architecture. Okay, so it depends based on your changes. You can do it. So I'll do a label. Okay, so what will I do?
But the kubectl apply commands, they were run in mini PC only, right? Not in Raspberry Pi, no?
No, it does. It doesn't matter. Okay, it's running the master. Okay, from the master, you don't need to worry about where you're running anymore. So you're running from the master. Okay. See, I can set up instead of this. Okay, in Windows, this kubectl. Okay, I can run in my Windows itself. Next time I'll try to do it. Okay, so it's a way to control. Okay, so this will send the commands to whom? APSO. Okay. Uh, does that solve? Does that answer your question?
So you're saying like the pods are getting created in the Raspberry Pi itself, even the command is running in mini PC?
No, no. Okay, so I'll come to you. Okay, I'll let me label this. Okay, so okay, so you're asking two things, right? How you're deploying it, right? It's a little advanced question, but let me try to answer it. Okay. So, so in your production environment, no one will give you access to master node. Okay.
Okay.
So it's like you have two nodes running. Okay. You will be able to connect with the kubectl. Okay. So let's say your sphere setup is running. So you will, from here, you will give a kubectl access from your PC. All you need is a token. That's it. You need a Kubernetes token. If you can get that, you can access this. Okay. Tomorrow, let's assume in the next sessions, let's assume how do you need to deploy the CA/CD as in Argo CD or something. How do you think Argo CD runs? So it also gets a token, right? As in you can say, let's say in your gym terminology, Jenkins. Okay, Jenkins or something, right? So it also gets a token and it will send the commands via kubectl to kube API server. Okay, so it doesn't matter wherever commands you're sending from, but you're sending the commands that directly it will talk to the kube API server. So does that answer your first question?
Yeah, yeah.
Okay, so now let me mark these labels. 1 second. So this is I'm just checking out. See, this one is the AMD 64. The other node is ARM 64. Okay. So let me label it. So, so I'm labeling my nodes. So this mini PC with AMD 64, the other one with the ARM 64. I can check the labels now. Okay. kubectl get nodes wide. kubectl get labels. Hyphen hyphen. Okay. So if you see, you have Arc 64 Kubernetes. So Arc and AMD. I think, yeah. So these are the labels that got added now. Okay. So we have a host name, K3s, but what we'll do is we'll use this one architecture label, or we can use any of the labels. We have a different labels here. Okay. So we'll use any of these labels and we'll mention, let's deploy this one in the mini PC going forward. Okay. So what we'll do, so front end, like right now it's a manual one. Okay. But I'll show you how to. I'm hard coding these ones to running. Okay. Let me commit it. Added labels per platform. What will I do? I will delete the deployments. Okay. So kubectl get pods, kubectl get deployments. So I'll mention kubectl delete deployments. Backend I don't know. It will take all. Okay. And Mongo. And also delete the services, kubectl get svc. So delete service, backend, frontend, and Mongo. So usually what people do is instead of aliases, we'll keep aliases. So we'll do that next time. We have, I think we have volumes also get created, right? Okay, we didn't got volumes created here. Like everything cleaned up now. Okay. So let's push. Let's check if your changes got pushed. Yeah, 1 minute ago. Okay. Now it's trying to push the images. Yeah, with the Docker buildx, it's trying to build the images. That's okay. All we need is Kubernetes deployment files to be updated. So that is done. Uh, Let me do a git pull for that. Better. Yeah, we are almost at the end of the demo. Like we won't take much time. So yeah, we have these files changed. So now let's do the let's apply it one more time. Kubectl apply -f. I'll remove still ingress is in .txt, so it won't get applied. So kubectl apply -f, but let me remove it. Ingress/10. Okay. Dot. Let me see what is the decoding error. Okay, it should be under a different place. Let me update it. recommit it one more time. I'll keep it here itself better. So let me vi backend.yaml. Okay, it's little difficult to do it here in the UI. Let's see. I'll try it again. Okay, so this time it recreated all the deployments. Okay, so let's watch the deployment. So kubectl, let me update the view for you. Yeah, kubectl get deployment. So it's saying it's ready. So let me check the pods. So the pods are also ready. Let's check the services. So the service is ready. If you see my front end is exposed on port 30080. So what will I do? I'll check my cluster as the master node, wherever this is running node port, right? Since it's got exposed. So I'll check for this one for the 30080. Okay. So I can check it from here itself. Curl localhost. So yeah, it's showing up. So let's check in the UI. Yeah, so we have application showing up. So as I told, I changed the UI a bit. So to look it neat. I think there is a problem here, but wait. Yeah, that's some UI bug is there, but we are getting the list. Okay, so our app is running. Now, the one you part we discussed yesterday, right? Like where we discussed about the ingress. Okay, so we'll use that. Okay, let's see what is there in the ingress. Okay, so what is there in the ingress is, so we are saying our ingress controller is Traffic, which is something similar to Nginx. Okay, and we are also saying we want to access our application in the slash, which is the direct URL and the port number 80, and this is the service which is using it. That's front end service. Okay, and I deployed my host name also. This would be my DNS name where I'll be accessing it. So let's deploy the ingress. uh let's slash temp. Okay, cp slash temp dot and move ingress to ingress dot yaml. Okay, so kubectl, you can run the slash apply, it won't do anything. Kubectl apply hyphen f ingress.yaml. So yeah, I think it's using old command, but that's okay. So one ingress got created. So let's check the status. Yeah, so Ingress is running. So it's running in two ports, two addresses. So in my master and the node also, because it's running over the whole cluster. So we will see how to deal with that part later. Okay. So what we want is we want a DNS, right? So I think my local DNS is down. So I'll hard code a DNS entry now. So let's show you how to do that. So Notepad plus plus. I'll open slash etc. See, this is there is the reason why I'm doing it. I don't have what is it? I don't have local DNS manager, so I'll set it up later. So let's see. etc. No, not etc. etc. Host name. Sorry. Yes. C drivers Windows 32. Yeah. So this is my file. Let me open it. Yeah, this is a last step, just to, just to make sure we have end-to-end demo. So yeah, this is like, since I don't have DNS, I'm managing like this. So what is the URL I want? 174 and men.local. Okay, so let me copy paste it. So before doing this change, let's check the NS lookup if my host name is getting resolved. Okay, see NS lookup man demo.local. No, I cannot find it. Okay, so I'm saving this. Yeah, the change got saved. I think it should be reverse way. My bad. So the change got saved. So let me see if I can undo NS lookup now. It got updated. Let me see. Okay, I think it's going via my DNS. So let me try with the local one. Okay, so just dig. But if I do ping, yeah, it's resolving locally. So I should be fine. So I'll open this URL, mandemo.local. We should be fine now. Yeah, and it's not secure. If you want secure, as I told you, need a CA, local CA. I'll try to set it up one, and let's test our application. Okay. So yeah, I think there is a UI bug with the opacity, but let me add. Yeah. So yeah, the demo completed. Let's review what and all we did. Uh, yeah, deployment. We tried to touch scheduling also. Okay, we try to touch ingress, and there is a manual DNS entry. Yeah, and I'll do a scaling, the last part, my bad. Okay. So far you've seen only how many pods running? One pod, I guess. So you've seen only one pod is running. So what will I do? I'll scale the deployment. So there are two ways to do it, but let me do it. Uh, Backend deployment replicas is equal to 5. Okay, front end. Yeah, I'll do an apply. No. Okay, unchanged. We should be good. And configured. It's got reconfigured. Okay, let's check our pods. So if I see my CPU utilization, okay, yeah, K3s is taking up a lot of things because it's trying to spin up the nodes. Okay, cube top, kubectl top nodes. Okay, so this is the utilization it's basically taking, like very least 1%. Okay, and let's see pods. Yep, this is the course it's actually using, so we should be good. So if you see, so we have this many pods running. If I go and kill one, okay, kubectl, uh, remove pod, I guess, delete. So now the deployment should be able to create a new one. Hmm. Okay, it created by the time I watch it. So let me do one more thing. Let me delete one more. Yeah, it's still inspecting actually the pod to go down. It will take some time. So let's do a watch. Yeah, I think it's still supposed to determine the health, whether the pod is got killed and all. So I think there is still lag over there. So we can see how to improvise that further. Okay. Yeah, I think the session went a little extra time, but yeah. So these are the things we explored today. So you can ask your questions. Yeah, there could be many doubts coming in how to do this, how to do that, and all. But so far, whatever the things we discussed, you have any questions?
Yeah, so just to confirm, like the pods creation and all is managed by like that API server only, right? So that's why, I mean, it will
Uh,
consider which node to create the pod in and all, right?
okay. See, all the authentication requests and all will be processed by API server. The scheduler will take care of that. The pod, controller and scheduler, they will take care of that.
Yeah, but we don't need to do anything. Like we just run kubectl command and internally this will take.
Yeah, this should take it.
So
Yeah,
that's
I
why when
think,
we mentioned that architecture thing, like internally it found out which one to deploy in and all, right?
yeah, that's correct. Let me delete all the pods. Okay. So, And I think since we are running very lightweight, right? Okay, the time it got deleted, it's recreating like 6 seconds. You seen that?
Okay.
So yeah, that's all. The scalability problem is solved. We don't want to remember the port names and all no more going forward. So that also has been taken care. Yeah. Any other questions you have? Yeah, Prasad, do you have any questions?
No, Sasi.
Yeah. So if you want to do it in your Windows, we can do it with the help of VMware and all. We can do that part. I can show you the demo next time. Okay. So like now I did in a Linux nodes, right? So we can do spin up a Linux nodes in our VMware, and we can do that part also. That also I'll show you. Yeah. Any other questions, Supreet?
So in the ingress part, like what we achieved is like, okay, that part I'm actually confused. Maybe can you repeat it like briefly,
Okay.
if possible?
What did you understood yesterday's session, like the previous session? What is the purpose of Ingress?
Yeah, like it's a proxy which will handle our user request and it will redirect the request to the actual backend thing or
Right.
the
So
service.
here mun.local is there. That's the username, right? See, mundemo.local, correct?
Yeah,
So once this request is created, so it will go to ingress, right? Ingress here, the ingress is, we have so many ingress you can do, like Nginx, you have traffic, right? The one which we used is traffic today. It's easy only. Everything is same format, okay? So now you have request, okay? So where you are supposed to send it to? Right? So you have front end. How many deployments you have? You have three deployments, right? What and all you have? You have front end, you have back end, and you have DB, right? So pods also three you have pods,
yeah,
right? How many services are there? So you have front end service and you have back end service and you have a DB. It's not a service. It's just there. Okay. So if you see here, like, so Mongo is also a service, but it's a local one. Okay. So if you see, there are two things. So one, cluster IP and the node port. Okay. So if you see this one, so this is a local one, cluster IP. Okay. This also is a cluster IP. And this is a node port. So what do you mean by cluster IP is, see these pods, they need to communicate with each other, right? Like yesterday you seen. So these pods need to communicate each other. So that's the reason we expose the service and it will be cluster IP. So it can be internal. That's okay. Now, this one, DB backend. So these two can remain in the cluster. The customer does not need to access it. Okay. But the front end, customer needs to access the front end, right? So that's the reason we defined as a node port. Node port as in you proxy the port forward this particular service. Okay. So this one port forward this particular service node port.
so this we
Uh,
mentioned in the YAML file for front end.
yes, exactly. So if you see, that's it. We mentioned front end and we didn't mention any port. Okay. We mentioned the container port. That's it. So if you go to front end, so it's the container port is 80. It won't change. Okay. And if you see this, so the port 80 got exposed to port 30080. Okay. Yeah. That is it.
The 30080 is on Windows.
He's on your master node. Okay. Let's change that also. Okay. So instead of this, 300. So you're right. That's a good question, actually. So we define the logic of ingress here. So what we'll do, we'll remove this, basically we'll remove this particular service here. Okay, like the node port service, right? Let's change this. So let's go here and let's go here and back. So we mentioned node port, we'll remove this. Okay, and let's go here. VI front end. Okay, kubectl apply -f front end. So the service got reconfigured. I'm deleting the service and let me reapply. So it's getting assigned because it's particular the IP, right? I think it's still getting node port, right? Okay, let me change the. So cluster IP. Yeah, I never tried it, but let's see if that works. Like something similar to yesterday. So if that works, we are don't want to expose the. So let's remove that. So now everything is internal. Okay. So front end, back end, front end, MongoDB, everything is internal. Okay. So no one can access it from outside. Like if I try the port number, I cannot access it. So now we'll tell our ingress to handle the thing. Okay. This also node port, right? Okay. But ingress, as you are aware, so ingress is already trying to connect to front end, right? So let's check the ingress status. kubectl get ingress. So it's still ingress, it's still active. Okay. Let's try to hit it. Okay. Yeah, it's working. So yeah, Subrit, does that give you answer? What is it you are looking for?
Yeah, yeah.
Yeah. So ingress will get the traffic as you told, where to go and all. So ideally, if there is no ingress, you will just expose it to node port forward and all. So I just removed that part totally. So now, so if you want to access backend, you will tell ingress that, hey, add an entry for backend. So it will go. So you'll get another URL. Or you want to access the database, you will tell. So ingress is your direction manager here. So there is a that's the reason I took one more session on Ingress, like how it works and all. As a it's nothing but a plain load balancer, right? Do you agree?
Yeah.
Yeah.
So this 192.168, it's the IP of
Okay.
mini PC.
Mini PC. Mini PC, or I can access it on Pi also. Okay, it doesn't matter. So let me 92 250. 250. Yeah, as I removed everything, now I just need to put the only the way I can go forward is with the URL, right? So yeah, and ideal production load. So this whole thing will get packaged, right? So like where you have these things, so you'll have the DNS, this one also. So like the whole thing will get packaged. So and that question you will also get answered. So right now, this is resolving to these two nodes. Okay, let's update the ingress. Okay, via ingress. So traffic I think traffic, it automatically determined this two nodes. Okay. So it particularly scraping the data from these two nodes. So yeah, that is it. So one is my master and one is my client. So maybe if it is a production setup, it will completely get changed. Yeah, let me try to hit it with port 250. Okay. I should not be. Yeah, I cannot access it directly. So the only way forward, I should ask Ingress, boss, give me. Yeah, no. Yeah. Any questions here, Prasad, Supri?
No, I think, yeah, this was a great session. It was too many concepts, but yeah, maybe in future sessions I'll get more
Yeah,
understanding.
as I told, I tried to keep concrete. Only three concepts I took today. Okay. And if you see all these sessions, whatever I covered till now, those were the basics. Okay. Ground basics to come to this place. Okay. And no cloud. Right now, I didn't wanted to go into cloud. That is altogether different concept. So it's basically you're reusing everything in the cloud. That's it. So if you understand this, you're good enough actually. So and any place you got a doubt, you can go back and refer what is it and all, and you can come back and you can use it. So yeah, next sessions I'll take the feedback. What to you can come up with ideas what I'm supposed to cover or something. So we'll see step by step. So as I told, Kubernetes is a long session. Like it might take around 7 to 8 sessions to get a basic, complete Kubernetes understanding and all. So, but we will try.
Yeah.
Yeah, Prasad, you have any questions, man?
No, Sasi, as of now, good with it.
Okay, let me pause. Thank you.